Spinning electrons are actually little mini magnets, but usually it's quite balanced and they cancel each other out. So you can see if it spins in one direction, it's a north upwards, and if it spins in the other direction, it's a south downwards. And so what you'll have is certain elements, which I'll show you here on the periodic table. These elements, so iron, cobalt, and nickel. These elements are the best because they do have some electrons in set orbitals that are spinning unbalanced, and so they are very good for having a couple of electrons spinning in one direction. So what you need to do is basically get them to line up. Once they all line up, that's called a domain. And so you can see here normally with most substances, the domains, the electrons are spinning all around the place. But if you can get them all to line up, we'll do that by induction, stroking it, or also electromagnetism, so we can put electrons in there and force the other electrons. We'll put a field and induce the other electrons all to line up in the same direction. So putting it next to a magnetic field, using an electric field, and stroking the magnet with a magnet to push them in the right direction are all ways to make these little domains line up, and so that becomes a magnet. You can either suspend the magnet from a thread or put it on a piece of styrofoam, and you can double check with the compass that the red end is the north end. Then we go to putting two magnets together. You can see that the two souths, the two blues repel, the two reds here also repel, and the red and the blue attract. So north south, so likes repel, opposites attract. Now diamagnetism is here, so you can see that there's a value of 200,000. That's a unit of magnetic strength. You can see how strong this is. So I'm going to show you some weak substances that are almost around zero or negative, very, very negative. And you can see, you can try this as well. Floating substances in midair, you've just got to have something to pull it a little bit away from the magnet, and you can have float it up right there, just like that. And you can design other substances by pulling. You can keep things floating by using magnetic force on both ends. Now, pyrolytic carbon here is the most diamagnetic substance. But as you learned from your study of electricity, the distance is rather large because it's so small. So at that distance, you're not seeing the repulsion, which is what diamagnetism is. But with these other substances, they're either slightly pos or neg. You can see that because the ends are really close to the plastic, the distance is much closer. I can move the magnet around, and I need to work against the twist of the string here. And if I just keep on putting it in one direction, I can get the copper to turn. Now I need to check if these substances are actually diamagnetic or magnetic, but typically they're called as non-magnetic, which is not true. Everything has an attraction or repulsion to a magnet, even water, every substance. So here we've got aluminium, which is classed as non-magnetic. So there's, I think that's some diamagnetism there, or weak magnetism. So moving on then. So we see the copper sulfate here is definitely not magnetic, and it's it's a very, very large crystal, so the electrons are trapped in directions. That's why crystals work particularly well. And so I've used a large crystal here. And again, this one's a little bit further a distance from the plastic edge because of the size, not as good as the larger pieces of metal. They're a bit longer. Creating a magnet now. So there's the first way we're going to use is induction. So using the magnetic field to put it creates a magnetic field in that magnet, and so now you can see that paper magnet, that paper clip is a magnet. Now if we pull it away from the magnet, it's no longer a magnet, so that one I'm holding there was induced. The second way is to get a stroker magnet. That's probably the very strongest magnet. Make sure you stroke it in the same direction each time. I've only done just a very quick one here with some strong magnets. You can spend a bit more time doing that. And then, as you can see, I can now lift up a paper clip, and also I can lift it in there just a little bit. There you go, and you can pull it along as well. This one's I've just done at school because having it only works with alternating current. So if you wrap coils, electricity in coils around an iron core, that turns that into a magnet. That's called an electromagnet. So you can see when I switch it off, turn the electricity off, there we go, and all the magnets fall off, and I can't pick them up anymore. All right. So it only works when electricity is going through. Now, field lines, using little compasses here, you can see the general shape of the field lines, and you can see how it turns, but it's a lot clearer if we use iron filings. So in order to get the field lines a little bit stronger, I taped them down and put them a bit closer and held them down. The big problem here is making sure the iron filings don't go everywhere, especially onto the magnet, because they're very hard to get off the magnet. And so just sprinkle them around once you've got your setup done, and then it should at the end look like this. And what I've done, just to make it a little bit easier because you can't see underneath anymore, I've just put that down here with the writing in there, so you can see the norths are repelling, the souths are attracting. Make sure you draw the line from the north to the south, because that's just the convention.